Financial Modeling, Topic 13, Forward Contracts. Section 4, Simulating Hedging Strategies. So let's continue with our example from the last time of Southwest hedging the purchase of 100,000 gallons of jet fuel in 1 year. Let's assume that jet fuel is expected to appreciate by 5% in 1 year with a standard deviation of 6.569, which I calculated using our data. And let's further assume that the appreciation is normally distributed and follows a random walk process. So what we're going to try to figure out is the distribution of unhedged cost. In other words, if they don't enter into a forward contract, what could be their cost of jet fuel? So I want to go to the spreadsheet. Notice I have at risk running. That's the add-in from Palisades. I have my inputs, 100,000 gallons of jet fuel. Spot price of jet fuel is $1.50. Expect to appreciate by 5%. I then have the jet fuel expected price of $1.575 next year, and a standard deviation I calculated at 6.569. So if I simply take my 100,000 gallons times $1.575, I get the expected cost of $157,500,000. So, but I want to figure out what it could happen based on the volatility of jet fuel. So what I'm going to do is I'm going to add a random variable for jet fuel prices next year, which are going to be equal to the current spot price times 1 plus the expected appreciation. And then I'm going to do a random variable, z, which is standard normal random variable, times the standard deviation. So in at risk, that's risk normal 0, 1. If we're doing a macro simulation, this would be the norm S inverse rand. But I'll take risk normal 0, 1 times the standard deviation. So spot price times 1 plus the appreciation plus a random variable times the standard deviation. Now, when at risk is not running a simulation, it's going to assume this, or it's going to have a static value of 0 for the risk normal 0, 1. So I'm just getting the same value here, 157.5. And then here's my simulated cost. I'll take my simulated spot price, A8, times my $100,000 quantity, and since this is a purchase, I'm going to make it a negative. But I'll then make this an output. So it puts risk output in front of the formula, and now I can run 10,000 iterations. What that's going to do, it's going to generate 10,000 possible spot prices of jet fuel next year. That gives me 10,000 possible total costs of jet fuel. Now the mean is going to wind up being 157.5. That's the mean of the distribution. You can see it right here. I'll make this a little bit bigger. And then you can see your full distribution. That's that normal curve because I use that risk normal as my assumption on the distribution. And you can see that my 90% confidence interval for total cost is between -173 and -141. So this is their exposure if they do not hedge the price of gasoline or of jet fuel. I also did a few more formulas in here. I used risk mean and then selected the output. So that's the 157.5. It's the simulation mean. I took the risk percentile 5% of that cost, which will give me my actually 5% highest cost or lowest number. So my 5% lowest is 173, my 5% highest is 141, and I took the standard deviation, risk STD-DEV of the output, so the standard deviation of jet fuel prices is $9,800. So this is a simulation of what Southwest exposure is to that 100,000 gallons of jet fuel. Now we're going to do is simulate a hedging strategy. Let's just pretend in this first example that they are able to get a forward contract on all of their jet fuel, a quantity of 100,000 at a forward price of 157.5, the expected spot price. What we'll do is we'll then add that forward contract to their underlying risk exposure to jet fuel and see what it does to their total risk. So what I'm going to do is I'm going to come down here. Let's say they can get a forward contract for 1 year delivery at 157.5. They're going to enter into a forward contract to buy 100,000 gallons. So let's get the simulated payoff of that forward contract. It's going to be the simulated spot. So we're going to get 10,000 possible spot prices minus that forward price, which is fixed, times my 100,000 quantity. So this is the expected payoff of the forward, which is 0, because in this example here I made a very simple assumption that the forward price is the expected spot price. I could make that an output. And what I could do, I could just run 10,000 iterations and just see the expected payoffs of that forward contract. And what you see, that forward contract has an expected or mean value of close to 0. It's like 12 cents. And looks like the 90% confidence interval is you make or lose $16 based on the volatility. So this is a risky contract. And their underlying exposure was also risky, right? We looked at this already. I'll do browse results. However, when I add these two positions together, which I'll do right here, I'm going to take my simulated forward payoff plus my unhedged simulated total cost. So this is modeling Southwest Airlines underlying exposure plus their position in a forward. When I add those two together and then make that an output and then simulate the hedged position with 10,000 iterations, every time that fuel price is simulated as a high value, in other words, that Z variable comes out to be a positive high number, the price of jet fuel goes up and they pay more for jet fuel. However, they get a payoff on their forward contract. And you get this really interesting histogram. Every single value is 157.5. In other words, they are perfectly hedged. The mean is 157.5, the 5% lowest, the 5% highest, and there's 0 standard deviation. They are completely hedged using that direct hedge on jet fuel with the exact quantity. So they're hedged. If they get this is not a cross hedge, they did a direct hedge with a jet fuel futures contract or forward contract. Now, many firms will not hedge 100% of their expected exposure simply due to the quantity uncertainty. In other words, what if they're not really sure how much jet fuel they need in 1 year? A lot of firms will hedge between, say, 50 and 75% of kind of that longer term exposure 1 year out. And so what would their exposure look like if they only hedged their 100,000 anticipated quantity with 75,000 on the forward contract? Well, all I need to do here is for the forward contract quantity, I can change that to say $75,000. That would be my hedge ratio is 75%. I've covered, it's also called coverage ratio. I've covered only 75% of my anticipated purchase. Now, when I run this simulation, the quantity is based on only a forward contract of 75,000, but they're still expected to buy 100,000. So now when I run that simulation, this is the hedged simulated distribution of profits, assuming a coverage ratio of 75%. And you see now their 90% confidence interval is between about 161 and 154. So there's a little bit of risk left, 161 and 154, but they are much safer than when they didn't hedge at all. Their exposure was between 141 and 173. So I'm going to change that back to a quantity of 100,000. I'll run it one more time and get ready for the next section. So in this topic, we calculated or simulated hedging strategies using a direct hedge of the asset. In the next, we will do a simulated cross hedge using correlated randoms in at risk.